Hello and welcome back. Today we're going to continue our series on exploring various design patterns. The pattern we're going to take a look at today is the Iterator Pattern. This is a pattern which provides you a way to access all elements within a collection of data without exposing the underlying implementation. On the surface, this pattern may seem fairly trivial or not very important, but what this pattern allows you to do is basically consume any sort of data and iterate over it uniformly without needing to understand how each data structure allows its data to be accessed. As a developer on the .NET platform, the challenge of implementing the Iterator pattern has been greatly reduced because the framework provides us interfaces such as IEnumerable and IEnumerator, which define us a common way to work with some of our collection of data. However, there's still a need to create the code that implements this pattern for you. What we have here today is an extremely simple example. I have a single object called player. It has a first name, last name, and a number. I have a repository here that's hardwired to return me a list of players in 3 different formats. One as a list, one as an array, one as a hash set. Now, in your day-to-day job, you're probably dealing with data in various different formats, whether it be in a list, an array, an XML element, you name it. The Iterator pattern will allow you to simply and easily iterate over this data without causing a lot of headache. So, the first thing I want to do at the end of this test, what I want to be able to do is do something like this. I want to do a move first. Let's call this it. I want to do a move last. And I also want to do a next. And have the ability to enumerate over them one after another. So that is our goal. Now the first thing I want to be able to do is actually want to create a mechanism that will create our iterators for us. So I'm going to create a class here called Iterator Creator. This will have a single static method on it that will return us an Iterator of type T. Now, I'm going to provide it something that implements the IEnumerable interface, and I'm going to have it wrap the implementation, because as you know, the IEnumerable only implements the getEnumerator. GetEnumerator will then implement things like move first, move last, but won't, or I'm sorry, will implement a current and a reset, but not a move first and move last. I want to implement move first, move last, as well as next. So now we've created our Iterator creator. Let's go ahead and create our class that is the Iterator. And this is going to implement IEnumerable. Now, I'm immediately getting some squigglies telling me that IEnumerable needs some interfaces implemented. So let's go ahead and do that now. Let's just go ahead and fulfill those 2 very simple interfaces. And I still have a squiggly up here telling me that I need to create a constructor that implements my call. I'm doing that right now. So now that help if I actually type this as T, that would make life a little simpler. So now that I've created my shell for my iterator, what are some of the actions I want my iterator to be able to take? I want to be able to do a move first. I want to be able to do a move last. I want to be able to do it next. And last, I want to reset. Now, if I was doing this and I was implementing it with a hash table, an array, or even XML, the way I would go about implementing the move first, move last changes based on the implementation. Well, fortunately for us, that isn't a huge issue. We can do return data. First, we're going to go ahead and use our handy dandy link here. Link will even further encapsulate how first is defined within our collection of data. If you're not using .NET 3.5 and you can't have link, then you do have to go through a little more pain and suffering here to implement the things like move first, move last. I want to do next. Now next presents us a little bit of a different challenge because the enumerable interface doesn't have the concept of current or next, and the linked syntax doesn't really provide us an easy way to do that. So what I'm going to do is I'm going to come up here and I'm going to create an index. We'll start this at 0. This index will allow us to iterate over the collection by doing next, and we can keep our pointer at that point. Now, if you don't want to use the next, and you simply want to do a for each over it, that's your handy-dandy get enumerator will come in handy, and you'd use like a yield at this point. So what I want to do here is do index ++ so we can implement our index, remembering it starts at 0. And I'm going to say return. So if the count is less than or equal to our index, we know we're within range. If not, I'll just go ahead and return a default instance of t. I can use a null here. If I don't want to do any of this and I want to throw index out of range, I can do that just by implementing the element add, as it will throw an out of range exception for you. And then come down here and I can reset index back to 0 on my reset. Now, if I've implemented my iterator pattern, let's bounce over our test harness. Now I said I want to fulfill move first, move last, and next. Let's see if I've done that. I'm going to save some fat fingered and a minute's worth of typing. I'm going to go ahead and paste in a test I've created. This test will basically demo the move last, move first, and next. Now, as you can see up here, I've just created 3 different ways, or 3 different lists of data in the different formats. I've created my iterator. I pass in each of these lists into the same method, get back the same object, and I can do move first, move last. Let's go ahead and run this unit test. And if I F10 over this, my first move first, I get a player. Move first, give me a different player. And then next would provide me somebody as well. So as you can see, in a matter of 8 or 9 minutes, we've taken a look at how you can implement the iterator pattern, which allows you to encapsulate the working with and traversing a list of data, and it hides the implementation from the user. So I hope you learned something, and until next time.